Hello, everybody. This is Shankar from System Based Labs. Welcome back to the course From Models to Autonomous Enterprise Systems, Module 3, The Rise of Deep Learning Systems, Video 4 of 6, Class 16, Sequence Models, RNNs, and Language Learning. Now, in our previous session, we explored computer vision and CNN architectures. We discussed how machines started learning visual perception. Welcome back to the course From Models to Autonomous Enterprise Systems, Module 3, and how CNNs transformed machine vision forever. But today we move into another major breakthrough in artificial intelligence history: language, memory, sequence, context. Because understanding images is one challenge, understanding information over time is an entirely different challenge. If you only see one frame at a time, without remembering previous scenes, the movie makes no sense. You immediately ask, what was unbelievable? Why? Because meaning depends on context. Human intelligence does not process information in isolation. We process sequences. Words depend on previous words. Sentences depend on previous sentence. Meaning evolves over time. Now, this became one of the biggest challenges in AI. Behavioral prediction, financial modeling, sensor intelligence, and sequential analytics. One input, one output, no memory, no context flow, no temporal understanding. But human intelligence does not work like that. Language flows across time. Speech flows across time. Behavior flows across time. Financial markets evolve across time. Sensor systems evolve across time. Enterprise workflows evolve across time. And this forced AI researchers towards sequence-based neural architectures. Now, this is where RNNs entered the picture, recurrent neural networks. Now, let us simplify this practically. Traditional neural systems process information once and move forward. But RNNs introduce something revolutionary: internal memory flow. Very important concept. An RNN does not simply process the current input. It also carries information from previous steps, which means the system starts building contextual awareness over time. Now pause there for a moment. Think carefully about what just happened architecturally. The system is no longer processing isolated information. It is processing relationships across sequences. That changed AI forever. Now let us use a simple analogy. Suppose you are watching a movie. If you only see one frame at a time, without remembering previous scenes, the movie makes no sense. RNNs attempted to solve this exact problem. They introduced sequential memory into neural systems. Now, this dramatically improved AI capabilities in language processing, speech recognition, machine translation, time series forecasting, behavioral prediction, financial modeling, sensor intelligence, and sequential analytics. Now, from an enterprise perspective, this became transformational. Customer conversations became analyzable. Speech systems became more natural. Predictive systems became time aware. Financial forecasting improved. Operational monitoring systems became context sensitive. Machines started understanding flow. Very important evolution. Now, another important concept emerged here: contextual relationships. Words change meaning depending on surrounding words. For example, bank. Are we talking about a financial institution? Other side of a river? Without context, machines struggle. RNN systems started improving contextual understanding by carrying sequential memory across inputs. Now, this was a major breakthrough at the time. But RNNs also had limitations, very important limitations. As sequences became longer, memory degraded, earlier information slowly disappeared. This problem became known as the vanishing gradient problem. Now, this created major difficulties for long documents, complex reasoning, and extended conversations. Machines still struggled with long range context, and researchers realized something important. Sequential memory alone was not enough. AI systems needed stronger contextual attention mechanisms. And that realization eventually led toward LSTMs, GRUs, attention architectures, and ultimately transformers, very important evolutionary path. Now, another major insight: sequence learning changed enterprise AI dramatically because real enterprise systems are sequential by nature. Customer journeys, financial transactions, cybersecurity attacks, supply chain behavior, human conversations, operational workflows, everything unfolds across time. And sequence intelligence allowed machines to start modeling dynamic behavior. Now, this also accelerated voice assistants, speech systems, real time analytics, language AI, recommendation systems, and conversational intelligence architectures. And eventually, these systems became foundational for modern large language models. Now, before we close, I want you to remember one important insight. CNNs help machines perceive visual reality. RNNs help machines understand flow, memory, sequence, and contextual evolution over time. And that became one of the foundational steps toward modern language intelligence systems. Now, in our next session, we continue Module 3, Video 5 of 6, Class 17 GPU acceleration, big data, and AI scalability, where we will explore why compute infrastructure, massive data sets, and parallel processing transformed AI capabilities globally. Because intelligence alone was not enough, AI also needed enormous computational power to scale. Thank you, everybody. This is Shankar from System Base Labs. Good luck and goodbye.